Okay, so carrying on with question 4, this is the reaction again, obviously, between hydrogen and iodine gases. And we've looked at the changing of volume and change of temperature for this reaction, but in this example, what they're doing is saying that the reactive reaction has increased, but this time it's done so when they've added a second or a third substance to it, namely cerium oxide. Because this has increased the rate of reaction and wasn't initially involved in the reaction, what we can assume that the cerium oxide is doing is, in this example, it's acting as a catalyst for this reaction and is helping to speed up the reaction by itself. Now, when that happens, the reaction equation, which initially obviously is a reaction between hydrogen H2 molecules and corresponding I2 molecules, that's making two hydrogen iodide molecules. Now, the cerium oxide, which is present in the reaction, is not included in that overall equation. And so, because it's a catalyst, and also because, as a rule, catalysts can be essentially removed from the reaction and obtained at the end of it, the reaction equation won't change because the cerium oxide, although it's involved in the reaction via a process of increasing the rate, isn't actually involved in the chemical changes overall for the reaction equation. So the reaction itself doesn't change, only the rate does. Now, we have energy profiles of that situation, and we are again using hydrogen and iodine, and we've been asked to do it with and without cerium oxide. So we're going to be asked to do two energy profiles, and we are specifically told that the energy of the products is lower than that of the energy of the reactants. So if we just arbitrarily place the reactants here, we'll label those R, we're told that the energy of the products is lower than the energy of the reactants, and so we have to then draw an energy profile diagram like that, and we will generally for these things label the activation energy, which is EA for this one. So EA in this example is without the catalyst, and what we're going to be asked to do is to then draw a second line where the activation energy is then lowered by the presence of cerium oxide, and so that profile will be starting in the same place, finishing in the same place, but this time the energy, activation energy, is lower, and this time this is activation energy with the catalyst, and so by lowering the activation energy, it allows the reaction to proceed at a faster rate than it did without.